Hi, today we're going to talk about geometric and arithmetic sequences. Again, we're going to the sequences B. We're going to recognize the difference between linear and exponential functions. As you recall, arithmetic sequences are f of x equals mx plus b. This is just slope-intercept form. And our geometric sequences are f of x equals a times b to the power of x. Okay, now it says identify the correct form of the following. Now, one thing I want to point out, it tells me that these values are when x equals 0, 1, 2, 3, 4, etc. So it's telling me that one of these terms is my 0 term. It's telling me my y-intercept in this case because it has that 0 there. So my first, I forget that pen all the time. My first term is going to be my 0 term, and that is 3. My second term is 15, but that's when x is 1. Then I have when x is 2, y is 75. When x is 3, y is 375. And it says etc., but I'm not going to do my fourth term. As you can see, my pattern here is a multiplication pattern, and it's times 5. So what is my function rule? Well, f of x is equal to my starting point, which is 3 times, that's my constant multiply, that is 5 to the power of x. Let's look at my next example. I have 13, 21, 29, 37. However, you'll see that it says when x is 1, 2, 3, and 4. It does not give me a 0 term, so it's calling this my first term. When x is 1 is there, that is 13. Then 21, then 29, and then 37. Well, as you can see, this is not a constant multiplication. It's actually repeat addition. I am adding 8 each time. I am going to have to back up my pattern to my 0 term in order to find what value goes here. So what number plus 8 will give me 13? And that is 5. So what is my correct function rule? F of x equals my change in y over change in x is 8 over 1, or 8. So 8x plus my y-intercept is 5. Next example, I have 3, 18, 108. And again, it says when x is 1, 2, 3, 4. At 1, it's 3. At 2, it is 18. 3 is 108. And 4 is 648. Wow. This looks like it's a multiply by 6 pattern. Is 18 times 6 108? It sure is. 108 times 6 is 648. So what would be my 0 term? What number times 6 would give me 3? That's 0.5, or 1/2. So what's my pattern? This is geometric. It's a constant multiply. So f of x equals my starting point, which is 0.5, times my constant multiplier, which is 6 to the power of x. I have another one. What's going on here? Again, it says 1, 2, 3, 4. This is, oops, gotta go backwards, sorry. Lost my pen again. So 1, 2, 3, 4. Then x is 1, y is negative 108. When x is 2, y is negative 36. When x is 3, y is negative 12. When x is 4, y is negative 4. Sometimes it's hard to see up here, but you can see right here that you might want to see you're dividing by 3, but remember that's multiplied by 1/3. Multiplied by 1/3. And 1/3 of 108 is 36. It's negative. So backing up to my 0 term, what number times 1/3 is negative 108? In other words, negative 108 times 3 will give me what? That's negative 324. Again, this is a geometric pattern because it's a constant multiply. So f of x is equal to my starting point, negative 324, times 1/3, not 3, 1/3 to the power of x. So question 6, I want to write my rule for this. It says this is term 0. Oops. Go again. Got to remember that. It says when x is 0, 1, 2, and 3. So 0, 1, 2, 3. We can back it up, see what's happening. Looks like this is a -3 pattern. -3, -3, -3. So it's linear since it's subtracting. So f of x equals negative 3x. And my starting point when x is 0 is positive 11. Next example, number 7. Oops. I missed my... Okay, so I was clicking. This is when x is 1, 2, 3, and 4. So this is 1, 2, 3, 4. If you look at my pattern, it looks like it's a times 4 pattern. So I do need to back it up to my 0 term. And if I said what number times 4 will give me 8, that would be 2. So my function rule is f of x equals my starting point, 2 times 4 power of x. Question 8. Again, I have 1, 2, 3, 4. I don't have a 0 term. Yeah. Someday I'll learn. Probably not in this lifetime, though. 1, 2, 3, and 4. This is a times 4 pattern. So what number would be here if I multiply it by 4 and I get 3? That would be 3/4 or 0.75. So my rule, it's multiplication, so it's geometric. F of x equals my starting value, which is 3/4, times my constant multiply, which is 4 to the power of x. And number 9. Again, it says 1, 2, 3, and 4. I don't have a 0 term, so this is 1, 2, 3, 4. You'll see I am subtracting 4 each time. So it is arithmetic, not geometric, but I do need to back up what number if I subtract 4. Ooh, okay. I accidentally clicked on my pen funny. I don't even know how to turn that off. Okay, that was interesting. So I'd have to start at 1, because 1 minus 4 will give me my negative 3. I don't even know how I did that. I'll be honest. So f of x equals, this is arithmetic. My change in y over change in x would be negative 4, so that's my slope, negative 4x. And my starting point was positive 1. Wow, this is interesting. We want to write a function for the pattern. What I would look at is how many of these little pluses do we have in each one of these. In my first sequence, when they don't tell you 1, 2, 3, or 4, or 0, 1, 2, 3, 4, always assume you're starting from 1. So that's my first picture, my second picture, my third picture. There are 2 pluses here. There are 4 here. There are 6 here. So what is my rule? Am I multiplying or am I adding? To me, it looks like I'm adding 2. And if I backed up my rule, I would be starting at 0. So it's my rule, y, or f of x, equals 2x. And it'd be plus 0, so I don't have to write that. But this example, my first shape or pattern is a 1. My second one is 1, 2, 3, 4. My third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can see that this is a times 4 pattern. My rule then would be f of x equals, what would be before this? What number times 4 equals 1? That would be 1/4. I guess I'd have like a little limb on that plus side. 1/4 times 4, my constant multiplier, to the power of x. I forget to clear. I'm doing all sorts of things wrong today. Let's look at my next example. I have 1, 2, 4, 2, 4, 6, 8. This is a times 2 pattern. But what would be my starting point? Well, if I back this up to a 0 term, what number times 2 would give me 1? And that would be 1/2, my 0 term. Put a 4 here. It should be an x. I don't know why I put a 4 there. Because looking at this 4. So what's the difference between when x equals 0, 1, 2, 3, or when x equals 1, 2, 3, 4? Well, when x equals 0, 1, 2, 3, you're given the y-intercept as a first term in the sequence. When it says x equals 1, 2, 3, 4, you're going to have to back up your pattern to find the 0 term. That's it. Have a great day.